Welcome to the MATH2 module. In this module we're going to talk about linear algebra, and this subject can be found in the reader. And we're going to talk about languages, and this topic is discussed in the book. And the book is of course again our discrete mathematics book from Lipschutz and Lipson, and the reader you can find on the MATH2 lecture channel, as well with the exercises, some answers and the mock exam. All videos can be found via the course description, and that is given in the general channel, and in this course description you will also find the topics discussed every lesson. Again, I hope you enjoy this module. If you think why we would do linear algebra, then there are several applications where you really need to know about vectors and lines in space, etc. And the most important one for technology environment is the second one, the imaging applications. Maybe you know that I worked at Philips Medical Systems before I became a lecturer, and I was involved with digitalizing the vessels of a patient with cardiac problems or cerebral problems or something like that. And for those applications, we really needed to know how to position something in space. We needed to know where the vessel was located exactly in the skull in a three-dimensional environment. So we used X-rays in several positions to calculate this. After this course, I hope you will have a better insight of how to do this yourself. Second part of this course will be about languages. And languages are of course very useful in the compiler area. New languages need to be developed compilers for it, code generators, etc. But also we will use the languages to create finite state machines. And again, finite state machines will help you enormously when you are programming some big application. You will learn more about finite state machines in object-oriented development, where it's one of the subjects. Okay, let's start with the linear equations. So let's start very simple. What is a linear equation? It's very simply something with an expression with one variable in it. And so for example, the first one, 4 times t plus 12 equals t minus 3. That is a simple equation with only one variable in it. And we can solve this. And we can put the t on the right side to the left, and then we have 3t. We put 12 to the right, and we would have 3t being minus 3 minus 12. So 3t being minus 15, so t would be minus 5. The second variable, the second equation we can't solve because it has two variables, y and x. And that means we have numerous combinations to solve this equation. For example, if we choose x being 1, then y would be 9 to have a nice answer to this equation. And you can figure out that if we look at all the possible solutions, then these solutions will together form a line. With this line having two specifics, the element in front of the x, which is in this case 5, is called the gradient, and this one here is called the vertical intercept. This 4 indicates on which position the line intercepts with the y-axis. So it's the vertical intercept. If we have two linear equations like these two, then we of course have two lines, and these lines will cross at some point, and this cross can be calculated in two different ways. We can first try to find the intersection point by just drawing the both lines and then looking at the drawing and see where the intersection point will be. Two other ways of doing that is called the elimination and the substitution method. Let's first have a look at the elimination method. And the word already gives the method away. It tries to eliminate one of the variables. And then we look at the two equations and we look at what variable would be easiest to remove if we add or subtract or multiply some of the equations. Well, and in this situation you see twice 4 times x. So the most easiest way to remove one of the variables is just to subtract the two lines. Then 4x minus 4x becomes 0. 2y minus 4y becomes 6y. And 8 minus 20 becomes minus 12. So this means that 6y equals minus 12. So this means that y equals minus 2. Okay, then we have figured out one of the variables and we can just use it in one of the equations. So let's do it in the first one. So then 4x minus 4, 2 times minus 2 is minus 4 equals 8. So 4x equals 12. So x equals 3. So the intersection point we calculated is 3 minus 2. And if you have plenty of time in the exam, you can always check. So just put it in both equations. Then we have in the first one 4 times 3 is 12 minus 4 equals 8. Check. And in the second one 4 times 3 is 12 minus 8 is plus 8 is 20. Check. So this is a nice way to calculate an intersection point. Another method is the substitution method, and then we substitute one of the variables with the help of the other. So what we need to do is take one of the lines, so let's take L1, and then represent one variable with the help of the other. So let's choose y. So then 2y would become 8 minus 4x. So y would be 4 minus 2x. Okay, and then we substitute this y in the other equation. So in L2, 4x minus 4 times 4 minus 2x becomes 20. So 4x minus 4 times 4 is minus 16. Minus 4 times minus 2x becomes plus 8x equals 20. So 12x becomes 36. This minus 16 goes to the other side. So x becomes 3. Okay, and then we only have to use this substitution one to figure out y. So y becomes 4 minus 6 equals minus 2. So the intersection point again is 3 minus 2. Substitution method. On the exam, by the way, we're going to definitely ask you some of these things as a question, and then you need to know the difference between the elimination and the substitution. And later on in the lessons we will figure out a third way to do it. Hope you enjoyed this first lesson, and see you in the languages and in the other lessons of linear algebra.